Hey there, tech enthusiasts! Today, we're diving into the fascinating world of network communication. Specifically, we're tackling the OSI model. Imagine you're sending a message to a friend across the globe. How does your message traverse the intricate web of networks and arrive at its destination? That's where the OSI model comes in. The Open Systems Interconnection, or OSI model, acts as a blueprint for network communication. Think of it as a 7-layer cake, each layer with a specific purpose. This layered approach simplifies things, making it easier to develop and troubleshoot network technologies. It's like a universal language for all things networking. Why should you care? Because understanding the OSI model gives you a superpower, the ability to visualize and comprehend the magic happening behind your screen. It's like having X-ray vision for your network. Whether you're a seasoned IT professional or just starting your tech journey, the OSI model is a fundamental concept you'll want to master. So buckle up and let's explore the wonders of this networking model. Now let's unwrap each layer of our OSI cake from the bottom to the top. First, we have the physical layer. This is the foundation. It deals with transmitting raw data bits over a physical medium, like cables or radio waves. Think of it as the physical pathway your message takes. Examples include Ethernet cables, network interface cards, and hubs. Next, moving up, we have the data link layer. This layer ensures reliable data transfer between directly connected devices. It handles error detection and correction, ensuring your message arrives intact. Switches and bridges operate at this level, managing data flow within a network. Then we reach the network layer. This layer is like the postal service of the network. It's responsible for routing data packets across different networks, like a GPS for your data. IP addresses and routers are key players here, ensuring your message finds its way through the vast internet. Now we're getting to the good stuff. The transport layer ensures reliable and efficient end-to-end delivery of your message. It segments data into manageable chunks and handles flow control, preventing network congestion. TCP and UDP are the heavy hitters here, each offering different levels of reliability for data transmission. Moving on, we have the session layer. This layer manages the dialogue between applications. It establishes, coordinates, and terminates conversations between devices. It's like setting up a phone call, ensuring both parties are connected and ready to chat. Think of things like NetBIOS and RPC here. Next up, the presentation layer. Presentation matters. This layer ensures data is presented in a format both the sending and receiving applications can understand. It handles encryption, decryption, and data compression, making sure your message is secure and legible. SSL TLS for secure web browsing is a prime example. Finally, we reach the top. The application layer is where users and applications interact with the network. It provides services like email, web browsing, and file transfer. This is the layer you're most familiar with, as it's where you directly interact with applications. Let's make this more relatable. Imagine sending an email. First, you hit send, and electrical signals representing your email data zip through your Ethernet cable. That's the physical layer. Next, your network interface card adds a MAC address, ensuring the data reaches your router. That's the data link layer. Then, your router uses IP addresses to figure out the best path for your email through the internet. That's the network layer. Your email is broken down into packets, labeled with TCP headers for reliable delivery. That's the transport layer. A session is established between your email client and the receiving server. That's the session layer. Your email is encrypted for security. That's the presentation layer. Finally, the email application sends and receives the message, making it appear in your friend's inbox. That's the application layer. Section 4. OSI versus TCP IP, a tale of two models. Now you might have heard of the TCP IP model. It's another networking model, and it's the one the internet actually uses. The TCP IP model is a bit simpler, collapsing some of the OSI layers. While the OSI model is great for understanding networking concepts, the TCP IP model is what makes the internet tick. Think of it like this. The OSI model is the theoretical blueprint, while the TCP IP model is the practical implementation. Both have their place in understanding network communication. Section 5. The enduring relevance of the OSI model. So, is the OSI model obsolete? Absolutely not. Even though the internet primarily uses the TCP IP model, the OSI model remains incredibly valuable. It provides a common language for network professionals, making it easier to design, troubleshoot, and discuss network issues. By understanding the functions of each layer, you gain a deeper understanding of how networks operate. This knowledge is essential for anyone working in IT, from network administrators to cybersecurity specialists. So, there you have it. The OSI model might seem daunting at first, but once you break it down, it's a logical and essential framework for understanding the magic of network communication.